Welcome to BC Gnomonics. In this video, we're going to be going over some brief details surrounding horizontal and inclining sundials. To start, let's imagine a dial that is required to have its hour plane parallel to the local horizon, that is, tangent to a given point on the Earth. Here we start with an equatorial dial, and as you can see by the diagram here, the only place this dial will be accurate until accurate solar time is at the North Pole. Keeping the design parameters in mind, we slide it down to roughly 35 degrees on the globe. And as we see, while the hour plane may be tangent to the surface of the globe, that is parallel to the local horizon, the gnomon has fallen out of alignment with the axis of the Earth. Therefore, this dial will not work in its current configuration. However, let's replace this dial with another one that still has its hour plane parallel to the local horizon, but a gnomon that's adjusted to be parallel with the axis of the Earth. As you can see, this dial is a horizontal dial and fulfills our design criteria perfectly. As you can see by this lower diagram, this is how the dial would look to local people on the surface of the Earth. Now, this clearly demonstrates how a horizontal sundial works, but what if you're given a dial that's designed for a location other than the one you want to use it at? This is the strength of the inclining dial, as by including a latitude scale or by installing a wedge beneath a dial, the dial can be inclined to a degree complementing the one it was designed for, which allows it to be used at a location other than the one it was originally drawn out for. Now, for example, this dial was drawn for 35 degrees, and as such has a 35-degree gnomon. Now, by inclining this dial to, for example, my current latitude of 44 degrees, we have corrected this dial. So now it can be used at 44 degrees. The angle of the gnomon has been supplemented by the angle of this inclined tilt and is now, when set on the local horizon, 44 degrees. This allows us to use this dial at a location other than the one it was designed for. Essentially, this dial repositions itself so that it is parallel to the local horizon at the location of its original design. That will conclude this demonstration, and I thank you for watching.